supervision and quality assurance, right? It's absolutely critical. But unfortunately, as Adele was talking, the price pressure on all of these projects, the first things that get cut are quality assurance and risk management every time. So the industry has got to hold the line on that if it's expecting a better outcome.
Welcome to episode 2 of PV Unplugged, the infrastructure of reliability and bankability, where we're talking about the burning issues facing the solar industry today. My name's Jonathan Gifford, and I'm your host. We're focusing on PV durability and O&M in this episode, as solar takes on an increasingly important role in our energy mix. Investing in reliability matters more than ever. But manufacturers are also under intense cost pressure, and financial sustainability is tough. So how do we strike the right balance then between reliability, durability, and cost? My co-host in this episode is Andrea Viaro, the global head of large-scale renewable energy for Stäubli. Andrea, welcome to PV Unplugged.
Thank you, Jonathan, and hello to our guest as well. And it sounds like a classic dilemma, what you're just saying, right? So on one hand, optimization of costs and supply chain. On the other hand, maintaining quality high. And as you said, probably more appropriately, durability over quality. So quality maintained over time, over the life cycle of the PV plant. So the question is indeed how to reconcile this dilemma in the end, which is, in my understanding and also in my experience with tier one or leading manufacturers, for instance, the real challenge and responsibility above that, in sense of supporting the industry with cost-effective solutions and maintaining quality high, and probably also together with that, the possibility to innovate and to support the industry with new evolution of products and technologies, which sets another challenge additionally, which concludes probably in a trilemma in the end. So balancing on that is really the major challenge in my view, especially in a young industry as it still is the PV sector, and especially in a commoditized environment where components are less and less appreciated in terms of quality over the pressure of cost optimization. And I'm very keen to hear the insights of our two guests today on that topic.
Well, thank you, Andrea. And I really like that distinction between quality and durability, that durability is in fact quality over time, over the lifetime of a project. Well, let's introduce our guests. Adele Zhao is the head of marketing, product and service in Europe and the LAC countries for Trina Solar, and Will Hitchcock is the founder and CEO of Above. Thank you both for joining PV Unplugged.
Thank you for having us.
Thank you, Jonathan. Very pleased to be here. An interesting debate, I think, that needs to be had.
Excellent. Well, let's get stuck into it. Andrea.
Perfect. I would go for the first question to you, Adele, and starting from the fact that you have had a long career in Trina Solar, and I was wondering what's your understanding of the biggest challenges that you see when it comes to components durability and quality and PV systems in 2026, for instance.
Yeah, I think you already mentioned about it. So we have, as an industry, we have huge cost pressure. So we have to do lots of costs down. One is on the component level, but also at system level. So, and extremely competitive market among the component supplier, but also among our customer. So, and then how to maintain the high quality as an industry is definitely, I think, one of the biggest challenge for the industry. As we know, solar power plant, at least for the module warranty, minimum is like 25 year, usually now go for 30 year. How do we make sure a real durability? Because today we have to do all the tests in the lab, but how to simulate that in the long run. So, and to make sure we have energy security everywhere in the future, because In 30 years, majority of the power, the energy source will be renewable. So will these power plants still be very functional with high quality, right, in 20, 30 years? So with the current cost structure, how do we keep the assets very healthy in the long run? I think definitely it's the biggest challenge. I think that's why also very interesting. We're going to have the discussion today as to how we can make it work.
Thank you, Adele. It's indeed, as you said, a challenging environment, a very competitive environment. I agree on that, definitely, especially when overcapacity happens, like in this period. How challenging is then to meet the expectations of the EPCs, the investors, in terms of durability, when the expectation is to have a plant which is lasting for, as you said, beyond the warranty terms, for instance, and to support the business case, the investment, to make it profitable ultimately for them.
Yeah, so I think I would like to make 2 points. One is you mentioned on the supply chain side, overcapacity of solar module. Actually, another industry have the same, for example, battery, they also have overcapacity on module particular, so it makes the competition not very healthy. So we have to compete without margin, and we have to survive as a company. So it's really, really difficult. So that's why we have huge cost pressure. We have to increase the efficiency, every part of the company, right? So this is the huge, and still the competition we just see very extreme, particularly in Europe, because Europe is relatively higher price region. So when we have overcapacity, right, globally, so and then even more competition rush to Europe to compete. So this is a reality, not just for module, for every component, basically for solar. So this is what we face. And another part is on the downstream side, right? It's not just overcapacity of the upstream. The downstream, we also face, we had a hype several years when the Ukraine war started, because everyone was scared, and particularly residential, we saw a boom, and we expect electricity price going to spike, which happened. We caused a lot of inflation also in Europe, and then but it got relaxed, which is good also, of course, for the society. But then it gave us a huge pressure to our clients, right? Because then they have less revenue also for the solar power plant. And then we know our today's energy infrastructure is not fully ready for renewables. So the grid expansion is much slower than solar and wind, right? And then we have a lot of issue in many countries, for example, negative price in Spain and Germany, in many other countries, basically outside of Europe. So it make our customer also have huge pressure. And they have to compete brutally also with each other, EPC and developer, Andrea, what just you mentioned. And so it's not just the overcapacity, the whole chain is highly competitive. I talked to the EPC a lot, and they say, well, we have huge pressure. Every penny counts, right? So it means it's not just a module, it will be inverter, mounting structure, EPC construction costs. So this is the reality we face actually as an industry. How do we achieve reliability or durability with this cost structure? So this is, we definitely need to talk about and find a solution.
Yeah, well, and as you've both said, Andrea and Adele, you know, the cost pressure runs right throughout the supply chain. So that means EPC, that means subcontractors, which makes actually construction itself, installation itself, crucially important for durability over the long term. Will, to bring you into the conversation, how about during the construction phase of a project? What more can be done to ensure that things are being installed correctly?
So I think within the construction space, the opportunity is there's a need to increase the amount of oversight and supervision of all the activities going on site. So I think what we're seeing is an increased use in other approaches to monitor the construction QA. So QA mustn't be something that's just done at the end of a project. It's got to be built into the whole construction process. Because these assets are so large and you've got huge teams of subcontractors that might be unskilled, or, you know, they're nested subcontractor entities involved in a project, you've got to be really hot on quality assurance throughout the build. Otherwise, you end up with this kind of drift. If a methodology isn't being followed and you don't catch it early, then you've got thousands of components installed incorrectly. So that the kind of oversight piece is a massive challenge because these sites are so big. So what we're seeing there is the use of things like aerial construction monitoring and better digital tooling throughout the construction process. This is often kind of nested in with what was the more traditional owner-engineer scope. So that's definitely one thing that we're seeing to kind of address this need. But it is a challenge. You know, getting skilled labor into these projects is a real challenge for the rate we're trying to grow as an industry. I think the second thing that is worth a mention is we're seeing a lot more buyers of modules utilizing pre-shipment testing, factory audits. So that's becoming much more of a norm now, which is encouraging. And then obviously post-shipment. So how does this stuff arrive on site when you do that handoff to the EPC? So having that kind of end-to-end QA from factory to field, and then on top of that to table, right? So you get this full traceability from manufacturing, shipping, arrival, installation, and the field piece. Once it's on the table, there's a lot of room for damage when things are being distributed and handled on the field, right? So this last point, whether you're doing some more sample in situ electroluminescence or drone thermography again at that point, is absolutely critical. And what we've been developing are solutions to bring this data together. So I think the insights that you can glean from pre, post, and then post installation will then sort of act as a sort of a really rich baseline for the asset going into its operational life. So to summarize, supervision and quality assurance, right? It's absolutely critical. But unfortunately, as Adele was talking, the price pressure on all of these projects, the first things that get cut are quality assurance and risk management every time. So the industry has got to hold the line on that if it's expecting a better outcome.
Thank you, Will. Very insightful indeed. And of course, as you summarize, supervision and quality control to ensure quality over time, as mentioned earlier. Coming back to PV components, modules in this case, Adele, as Will mentioned, supervision and quality control, pre-shipment inspections, for instance, are key to maintain the quality throughout the value chain. How do you think that, considering the fact that PV modules or PV components in general are part of a system, could help to improve the reliability and the durability of the PV plants for the market?
Yeah, I think there are many two parts, but I can pick one, so mechanical and electrical. I think these are the biggest two parts. I would take one more precise example for the mechanical part. I'm managing the pre-sales, mid-sales, and after-sales for Trina in Europe and LUC at the moment. So I see how actually our customer handle this part. So we call it, like, there's an interface risk, right, in the APC part, basically. So is module compatible with mounting structure, right? So over the time, I see customer have huge basically a cost pressure. We also mentioned in the construction subcontract. So it means down, they also have to do a lot of cost down. Do we have skilled labor? Do we have qualified engineer to make sure these components actually are compatible? So it's not even haven't reached the pre-shipment. So the designing phase, the E part, is it done properly? I cannot name which clients, but sometimes I got shocked after so many years in the industry. I have some customer in Germany. I think they're like super experienced customer, and then at the last stage, before we're gonna deliver the module, and they say, hey, this part of the mounting structure, can you validate it? Issue a letter, and then you will see, but it doesn't match our user manual. And they went probably for a cheaper version, right? So like these needs to be verified very ahead during the engineering phase, because every project is different. And then also it's a long-term asset. So you have to count a lot of future risks into the project and make sure the system, module plus mounting structure plus the foundation, also how terrain gonna change over time, all into consideration to make sure these mounting structure and this earth gonna hold the modules so they don't collapse or the module don't get damaged. This is the basically, but I see in reality, we don't have the best practice in sometimes. So in my daily work, sometimes I got pushed. So the mounting structure is produced, module are produced. I got pushed to sign certain letter. I can't basically for Trina because it's not good. You will have a better quality asset. And eventually it doesn't just hurt that customer, it will hurt the whole industry. The whole solar will have bad reputation. So this is actually one of my best concern at the moment, looking at the system level. This is just one example to be very precise on the mechanical part.
Thank you, Adele. And indeed, yes, part of the responsibility as we have as manufacturers, I would say, leading manufacturers to really make sure that quality is produced, but then it's maintained throughout downstream the value chain and installed properly. As you correctly pointed out, Adele, I think compatibility or integration of components into the system to make the whole system reliable and durable is really key. And moving from hardware to software, for instance, we see a lot of developments also in the PV industry for digitalization and AI application, machine learning, and so on and so forth. So, Will, from your point of view, how this will help in detecting or preventing or troubleshooting failures in the field?
Yeah, I mean, this is our, the entire strategy of what we're working to is to bring this data together that's being created all the time in the field, in disparate systems, siloed data, and bringing that together in a way where it answers questions, predicts outcomes. Because, at Above, we've inspected thousands of assets over the last decade, and there are insights in that data. And it becomes richer and richer the more data sets you combine in the field. I think as an industry, we've been very poor at component level condition monitoring in a structured way, right? So the telltale signs of a component degrading over time. A great example is backsheet failure. It's my bugbear at the moment. The aging the assets from the subsidy era, a lot of them are suffering from backsheet failure. And it's the biggest cause of repowering at the moment in Europe, is my belief. And a lot of that degradation was happening over the preceding 3 years, right? It started to go yellow, it got chalk dust, and then it started to crack, then you start to get rhizo faults. But what we're doing is we're allowing these small component level issues to worsen until it starts to impact yield. And then we're on a back foot, and then we've got to wrestle with obsolescence because they can't get spares anymore, right? So using digital tools and data to monitor component condition over time will put you on the front foot of systemic issues like that backsheet issue, give you time to redesign the plant around obsolescence, whether that's phased repowering to protect yield, etc. Those opportunities are all there right now with the technology available to shift the way we approach preventative maintenance. And so I think that, and when you throw in the fact that these plants are getting bigger and bigger, and the biggest constraint we have to our growth is skilled human resources, right? We've got to be using them smarter, with smarter data captured at point of collection, and then using that to answer questions and target interventions before they become yield impacting.
It's interesting you say that backsheet failure with these older projects, these subsidy era projects, remains a major feature. We're going to address backsheets in detail actually in episode 5 of this series, so just in a few weeks' time. So thanks for bringing that up. Will, when we're talking about, backsheet is rear side, so you can observe, the dynamics within the module using drones. Adele mentioned, the EBOS side, the electrical DC cabling side of the PV system as a potential source of failure. In terms of aerial monitoring, how challenging is that, right? Because you're in the air with your drones. How can you see in detail in the rear side of an array?
Yeah, so the first answer to that is if the data from the front face thermography is presented in the context of a digital twin with the electrical hierarchy, you can actually go beyond just the module condition. You can see string failures, combiner failures, inverter failures. You can even see subtleties in MPP across the array. So thermography on the front gives a lot of insights to the overall DC health, not just the module, right? Having said that, what we're seeing now with the larger form factor modules that are bifacial glass is this concern, and it's a genuine concern. We're having a lot of customers come to us where rear side glass is cracking. And this is kind of catastrophic for the module in that it's immediately a health and safety problem and also a moisture ingress problem, right? So having a robotic solution for rear side inspections is definitely becoming a need area for us. And we're addressing that with trackers. It's possible when they're in sort of extremes of angle, either morning or afternoon or in hailstow, a drone can give a good rear side inspection for glass crack and MC4 connectors and things like, and junction boxes, which is another area of concern. But yeah, you're right. It's shifting from just front face to also the rear side because of that larger form factor module, that rear side glass risk. But also the junction boxes are now soldered in situ in production rather than an appliance that's added in assembly. And therefore there's cold soldering risks and other problems that are coming through as these modules are, out in the field. I think it's interesting, we talk about quality, price and durability. They are treated very, very separately. And I think the one with the least focus is durability in the industry. And the one with the most, decision making is price, as we well know. But I also think we need to take stock of technology evolving too quickly. So we're rolling out new module technology at scale very quickly with very little durability data because it hasn't been in a field long. And so that's a real challenge for the industry, I think.
Very good point, Will. And definitely that sets challenges for module makers, clearly, because technology evolves very quickly. It's clear every year we have new evolution of power classes or technologies developed by the manufacturers. And this sets clearly challenges on the durability because there is no data sets, as you mentioned, that can support really the information to confirm the risk management that also asset owners or EPCs are taking when adopting new technologies. So Adele, is there any evolution or development in a module supplier landscape like Trina, where also not only hardware but also digitalization or electronics can help really to support these digital twin concepts and facilitating the operation and maintenance or predictive maintenance, for instance, on the hardware and software side, so for mechanical or either electrical topics?
Yeah, so I don't know if you all know, so Trina acquired a tracker company several years ago. So it's called Trina Tracker. So, but in reality, we also do fixed structure. But I think the tracker is the interesting part. So it's smarter. So it basically has a brain. So I would say that's more. Also, we just mentioned actually when you move, you can detect the backside of the module. So I think it's really, really interesting. So we also focus a lot on the tracker. Because why? So digitalization of power plant and assets are essential. I remember 10 years ago when I was in the business school, we're talking about Internet of Things. Or I was like, okay, how are we going to use these things, right? It was a fancy term, but now we 10 years later look at it and say, okay, maybe that's what it is, right? We just digitalize these power plants, make it smarter, and basically, and they can think themselves because the power plants are getting bigger. And then Europe is still okay. For example, like Middle East, it's middle of nowhere. In China, it's like in desert. how can we have people and put people there and just maintain? It's just impossible. Everything has to become remote, basically, right? Maybe one day we're going to build on Mars, right? So we won't have so many people. So very
Sky's the limit.
important.
I like the ambition. I like the ambition, Adele.
Of course, we are a very ambitious industry.
Let's get it right on Earth first.
Yeah, good point. So we're trying. Maybe 4 smart brains today. We're going to find solution. But come back to the tracker. So I would highlight 2, very different comparing to the previous fixed structure, right? So one is actually about also prevent risk, particularly the climate risk. So actually tracker have safety modes. So wind, snow, hail. So you can build a very robust module. I don't know, I was joking with customers, if you want a bulletproof glass, probably we can do it if you want to pay for it, but probably we cannot afford it as an industry, right? So it doesn't make sense. But tracker can move the module to protect to an angle so they don't get hit by the hail, for example, right? And then the wind and snow is same. So the tracker can think and they will move, protect themselves. So this is something very important, I think, for assets. And then another part is how to also, because the cost of the component is one part, but we have to think about what's the resource constraint to do solar power plant. It's land, particularly in Europe, I would say. So we don't have so much land here. So if you use a low efficient module, let's say, you take lots of land, right? So that's like in Switzerland. So Andrea, the Jonathan in Switzerland, huge debates. Where are we going to put the solar panel? I also live in Switzerland. The mountains are so beautiful. We don't want to put power plant. It's a huge debate, right? So it's a constraint, natural resource. We're competing, and then we competing with farms. That's why we talk about RPV. So what tracker can do, for example, we also just mentioned the beneficial module, double glass. So how to maximize the energy yield with that amount of land and material we use for this power plant. So the cost down, one is to reduce cost, but also very important is to use less material, produce more energy. So that's also very important as any industry. It's not just solar. So it's not just getting cheaper, but use less natural resource, right? So then we go back to this power plant. How do we use less land, less raw material, glass, aluminum, whatever, cable, copper, because there's constraint, and then produce, right? So the new tracker, what they can do is, like in Trina, we have the super track algorithm. So it's basically monitoring real time the irradiance. So not just the direct irradiance from the sun, but also diffusing light. So, and then the algorithm is calculating itself. Okay, today I'm cloudy with whatever irradiance. What's at this point of time, what's the best angle of our module to rotate? So very interesting is actually in lower irradiance region, the performance gain, if you use these super track to move, is higher. The percentage gain. So it's a bit different from the common sense. People are saying, maybe Spain, for example, in Europe, the power gain is more. No, actually, for example, in Denmark, it's higher. UK as well, right? So this is how to maximize basically the production with less resource. So this is what the digitalization also can do. So again, to summarize, one is to prevent risk from natural disaster. Another one is how to use less resource, I think, to produce more energy. I think that's probably the main direction we're working on.
Yeah, it's interesting seeing the tracker reducing risk, often moving parts. I remember in Industry 1.0, people thought moving parts increases the risk. We'll just take a very short pause there and be back with PV Unplugged in just a moment. Welcome back to PV Unplugged. Our guests are Adele Zhao from Trina Solar, Will Hitchcock from Above, and my co-host is Andrea Viaro from Stäubli. Andrea.
Yes, interesting point, Adele. As you mentioned, how technologies evolution are actually helping to address specific problems. And in the past, probably technologies that were not easily accepted by the industry are now actually addressing and solving those challenges, as you mentioned for the tracker as an example. And a good point, in my view, also about reliability over climate challenges. We see more and more severe conditions happening in different locations, and globally, it's not easy probably to have one solution fitting all applications there. So, Will, you above operates in globally, so over a different range of geographies and conditions. So, how do you think designing and building PV systems for the specific local environmental condition could help to improve reliability and durability of the systems?
So I think, yeah, we get to see a sort of a global lens across thousands of aging assets, right, in different climatic conditions. So it's quite insightful in that regard, and we see sort of variations in way the equipment will survive in a saline environment, for instance. So coastal areas, there's definitely a difference in how susceptible they are to PID and structure corrosion, and also things like the cable connectors. We've seen scenarios where the cable connectors have been left during construction exposed, and in a saline environment that leads to, some issues once they're connected and operational, right? So that sort of consideration, I think we're also seeing in a lot of the northern European sort of temperate environment, and going back to Adele's point about space that is a premium, is that we see this quite compact array building still going on today. But, the aging assets, we're seeing the microclimate that leads to a kind of a biofouling risk, if you like, where the lower edges of these modules that are shaded for many months in the year create a microclimate for moss and lichen to grow. And then we've seen that get between the frame and the glass and start to break down that IP protection for the module. So that's definitely a consideration. So I think the way that you maintain, clean these assets and deal with that risk, which is just going to happen in that climate, right? If you continue packing these rows quite tight on fixed tilt, it will happen, and that leads to early life failure of modules. And then we've been involved in quite a lot of severe weather, sort of post-severe weather event inspections. So snow loading is one of them that we've seen more of, and wind. So I think the wind, this stuff is built using weather data from the past, and I think we need weather data for the future to really understand what these arrays are going to be exposed to. And it's very difficult to predict that, right? The climatic patterns are changing, so that's a big risk for the industry, is not building for the future weather. Hail events are another one that we've done a number of inspections on. So this plays into the glass thickness piece. But the interesting thing about hail and the whole hail stow solution is that hail is associated typically with convectional storms, and you get very high horizontal winds. And so that's not necessarily the best stow for both wind and hail. In fact, I don't think there is a stow for both events. So that's always going to be a challenge. So I think the summary is, building for climatic conditions has got to be considered, because some stuff will not behave the same in certain situations as well as it will in another. And then it's that whole maintenance, the cleaning piece, and factoring that in to the given setting.
Interesting. Well, indeed, yes, we have huge data sets for the past conditions, but not much about the future. So we can't really predict too much what will be probably modules also facing in the future in terms of weather, severe conditions, and situations. So Adele, from a module manufacturer point of view, how is Trina facing that or anticipating the future conditions where the modules will operate in terms of hardware and digital solutions to address that?
Yeah, I want to build on top what Will just said. It's about hail. Very interesting topic. So like Switzerland now. So is HW3 is enough? So, but on rooftop, and then because Switzerland mostly is rooftop solar. So now we're talking about HW4, but it's not mandatory yet. So it's a requirement from the insurance association. So we're related to the insurance, but they're already predicting and they're waiting for the data to collect 2025 data and see if the hail will get bigger, and then we'll enforce it if it happens. But they are basically insurance company, as you can imagine, they're more conservative, right? They don't want to pay, and then so they will enforce HW4. So in Switzerland, it's all like all the distributors start talking about HW4 as example. So from Trina side, what we do is we have called shield module. So they will have thicker glass. So we have one version for the rooftop, for example, Switzerland. We also have a utility one, a bigger one for the bigger power plants. And then what Will just said is quite interesting, is exactly the truth. So when hail happens, the wind is also very strong. So they conflict. So tracker cannot move to two positions. It only has one position. So that we also know that. That's why in that case, so you have to strengthen the module. So what we do is we tell customer, you recommend them, you have to use shield module plus tracker, because then the module, the glass is thicker, it can handle much bigger. It can go, I think, up to, I don't remember exactly, 55 millimeter hail. And then you can basically, the module can be more flat to handle the hail, but the more flat position to also protect the module against the wind. So that's the solution we have to in that case, because we do see more extreme case happening because of this climate change, to be honest. So this is one. So hail is definitely a big topic. And now, particularly on rooftop, a utility will come for sure, because we see it's increasing. And then another point is about the temperature, for example. It's also something I think interesting to share. So there is a new IEC standard, and then they put different, so 70 degree, 80 degree, and 90 degree. So it's new. In the past, the chamber test was all 85 degree operating temperature, but now new IEC has 3 levels basically, because of course, one, we can imagine, we do feel, I think summer is getting hotter somehow, right? The winter getting colder. So we have to get ready also for that. In 20 years, I don't have the crystal ball, how hot it will be. I hope not so hot, but the module, the whole system have to handle, right? And then actually when temperature change, as you can imagine, for example, the deformation of these material will also change. The module, the mounting structure, etc. So actually, we do really have to design the system for future, right? Because it's for the next 20, 30 years. So we need to give enough safety factor to the system to prevent this issue. Unfortunately, sometimes we have, again, huge cost pressure as an industry. How much do we put there to handle the future? We don't even know what exactly the risk sometimes, especially the climate risk. So it's a challenge. But if we can find a solution to give the buffer to be ready for future, it will be really good for the industry, particularly for our clients. Actually, really, really important to consider this.
Thank you, Adele. So I got from what you just said confirmation that clearly we need to go beyond standards and warranty terms really to be prepared for things that are not known yet. So managing the risk for the unknown in reality is really probably the key going on. Will, back to you. Beyond standards, you have your protocols when testing or inspecting PV fields or PV components. How are you going beyond that to be prepared for the industry, to be prepared to face those challenges in the future?
Well, I mean, there's not a lot of solutions to this severe weather other than building more robust components, right? But I think, what we're focusing on is how we increase human efficiency in the field and improve the monitoring and the condition, time series condition data over time. So I think we've got to start using humans more intelligently, smarter use of humans in the field. But then we've got the whole concept of using digital twin technology to power insights, to trigger activities in the field. We're now working a lot more with a future that will have more and more robotics within the context of solar, right? This is an obvious direction of travel for the industry. And I think the place to start introducing robotics, in my mind, is where the CapEx is less of an issue, is at construction. And then we talked about construction earlier. Bringing drones in boxes and ground-based rovers into that space at that CapEx point makes commercial sense every time. And I think the challenge with the operating fleets is that the O&M budgets tend to prohibit the investment of additional hardware or infrastructure in an asset. So I think my belief is it'll still wash its face. And if we can reduce human truck rolls and make the use of humans much more efficient and targeted, this technology should be being deployed in very large scale ground mount assets today, right?
Wow, fascinating. The use of automation and robotics. We've seen it, automation in particular, be deployed in factories throughout the solar world, where it not only increases efficiency, but also improves reliability, improves quality, repeatability. So it is an exciting future. In fact, you mentioned ground-based rovers. I believe Stäubli was an investor in an early investor in On-Site, I believe. Yeah, which was recently acquired. Good for those ground inspections, rear-side inspections. But unfortunately, as interesting as this is, and it's so often the case, we get stuck into some really fascinating topics, but we have run out of time. Thank you very much, Adele Zhao from Trina Solar, Will Hitchcock from Above. Thank you for joining PV Unplugged.
Thank you very much.
And thank you very much to my co-host this episode, Andrea Viaro, the Global Head of Large-Scale Renewable Energy for Stäubli. Thanks for joining PV Unplugged. I think it was a really great discussion.
It was a pleasure. Thank you.
Well, coming up in our next episode, episode 3, we'll be going deep on durability with an episode titled The Long Haul, Engineering Assets for 25 plus years. We'll also be talking technical due diligence testing, investor expectations, and insurance with 3 guests, Jörg Althaus from CEA, Madeline Hill from Everose, and Dreikes de Roy from Sinovoltaics. So keep an eye and ear out for that in the next week or 2. My name's Jonathan Gifford, and thank you for joining PV Unplugged.